Hey guys, what's up? Danny here, and today I'm going to be telling you how much snow you should expect from this big winter storm that's going to be impacting the Northeast, right? I'm going to be telling you about how much snow you should expect wherever you live in the Northeast. I already covered the upper Midwest, and currently the storm is impacting the upper Midwest, and looks like Minnesota is actually getting heavier snow than was originally expected. And it looks like Wisconsin is actually going to end up receiving potentially more snow than was originally expected, right? Because obviously the forecast always changes, right? So again, it does look like there's going to be too much warm air, and I would kind of stick with this forecast right here, because there really doesn't seem to be too much cold air, and again, there's going to be a slight ridge that's going to be uh, kind of fueling this warm air. So the coast, the immediate coast, might get a couple snow flurries, but in general, they are not going to be getting uh they're not really gonna get any snow. Okay, so let's take a look at the snow accumulations right now according to the GFS model. Um, so let's take a look at the NAM 12 km, and looks like in Pennsylvania and in the mountainous areas of Virginia, there's actually going to be freezing rain. In Maryland, the eastern part of West Virginia, the Maryland Panhandle, it's going to be receiving some freezing rain and sleet with a mix of snow. It looks like central Pennsylvania is going to get hit with first some freezing rain and some sleet, and then it's going to turn over to snow. And all the inland areas are going to get the most snow, and looks like this is also going to be a mainly rain event for Boston too, right? For Maine, looks like the immediate coast is going to get some rain, but the rest of Maine is just going to be plain snow, right? So let's take a look at the total positive snow depth change from all of these models, right? And this is about how much snow you could expect. So I do think that, the more mountainous areas could get up to about 12 inches of snow, or locally higher amounts there. Looks like, upstate New York, general 6 to 12 inch snowfall. Extreme western Massachusetts, go like in this pink and green areas, you should expect 6 to 12 inches, localized higher amounts, right? And that's basically the totals for the snowstorm in the Northeast. Through a 1 to 3 inch snowfall generally in Pennsylvania, extreme northwestern New Jersey, Maryland Panhandle, the eastern part of West Virginia, and the western part of Virginia. And then you could maybe expect to see a trace of snow in the hillier areas of western North Carolina. So that's kind of what I'm expecting right now with this winter storm. And as we go through time, all right, let's take a look at the radar, and let's go to the GFS model, right? So basically, as we go through time, it looks like there's going to be a lot of cold air in the Northeast, and there is going to be a couple chances for some winter storms, but it looks like it may actually be kind of dry in the northern part of the United States. And as you can tell, there's going to be a very powerful high up here, right? It's going to be bringing down cold air in through the north central portion and the eastern portion of the United States. So you take a look at the temperature anomalies, and you could tell how cold it's really going to get. So there's going to be winter blast after winter blast that's going to be in the upper Midwest and in the Northeast. So the temperatures are going to be below average in the next 2 weeks in those type of areas, and then you get into the long term. Then things change a lot. But again, we need to look for opportunities where a storm could kind of catch up to a trough and provide a lot of moisture and stuff. So let's actually take a look at some other weather models. All right, let's go to the Northeast, and let's go to the RGEM model, and let's take a look at how much snowfall it's showing compared to the NAM model from this one big, you know, snow event and stuff. So basically, the precipitation is going to change into snow in Pennsylvania. It's going to be briefly heavy in Pennsylvania, but then it's just going to either transition into rain, or it's going to so they're going to transition into rain, or maybe yeah, transition into like wet snow, because there's going to be a lot of warm air. As you could tell, as the storm is really, really close to the coast, you can see the warm air going all the way up through upstate New York, even rain showers or wet snow showers in and around this area. Again, just, proving that the temperature at this time is still not that low, right? A lot of areas where it's going to be snowing, it's not even going to be below freezing and stuff, right? So that's a very important factor that you guys have to think about. So again, I would stick with the NAM model. I think it is actually very accurate with the snowfall amounts that it's showing. And then we have this model. Let's just take a quick look at it and as to what it's showing. And all the models are basically in agreement with kind of the same thing. Every single model has like kind of the same type of gist to it, so I wouldn't really expect that much in the way of snowfall in the coastal areas. But yeah, okay, so let's take a look at the ensemble GEFS. Let's just take a look at the current weather pattern right now with the 7-day precipitation anomalies. Let's take a look at the 06Z, and we take a look at the precipitation anomalies. And the GFS model came out with a one result, but as you can tell right here, it shows again a lot of moisture down here, right, going up the coast. And while at it, the temperature anomalies are like way below average. So again, that shows that the ensembles are actually showing potential for a couple snowstorms. So let's go to COD meteorology, and here I can take a look at the GEFS ensembles, right? Hold on. Ensemble precipitation type, okay. So let me just like kind of go through this real quick. So, it's an incomplete data set. Okay, so we have to go to the 06Z, and then we could take a look at what we're going to be expecting. So again, the storm is going to come through, and as we go through time, you take a look at all these weather models and stuff, and there's actually, again, some of the weather models here are hinting that there's potential for a winter storm around 198, hour 198, which is December 22nd, right? So we have a snowstorm set up in this model, this model, this model, this model. Every single model is kind of showing a really, really big storm, but it's showing very, very different outcomes for that one specific storm, right? But that is definitely a time frame you guys have to watch out for. In about 8 days, a lot of models, they're showing something extremely big going on. And let me show you guys the perfect model scenario. That would basically mean the Northeast gets a lot of snow. Okay, so let me just look through this period real quick. Let me see which model is kind of showing the biggest snowstorm. Literally look at all these models as I'm going through them, and you can see every single model is showing a snowstorm, and some models are showing rain for the East Coast and some models are showing snow. But I would say right here, there's a model right here. So if you really zoom into this one, where I don't know if you guys can see my mouse, but ensemble member 12, you guys can see that there are two pieces of energy that collide together with a ton of Arctic air on the backside. There's a massive winter storm. So this is kind of the main like kind of jet stream setup. You know, there's going to be a lot of moisture coming in from the south, colliding with extremely Arctic air. Now this is the thing: a storm gets very powerful when there is an extreme amount of, like, you know, we have tropical air colliding with Arctic air, and that can produce lightning, thunder, and if the air is very, very cold, the people get more snow, because the drier the air, the higher the snow to liquid ratio is, right? So instead of being an average 1 to 10, it's going to be like 1 to 20 or 1 to 30. So again, keep that stuff in mind, guys. And so as we continue going through these models, right, we see that there is many more times where there's like potential for, like, you know, snowfall in the northeast. And most of these models, they're showing more cold air in and around the northeast, and they're showing less warm air. So more snow for the northeast, and yeah. Okay, so let's take a look at the reason why this cold air is going to be going down. So if we take a look at the North America viewpoint, and then you take a look at the 500 MB height anomaly, right? It looks like, yeah, the trough in the east is going to continue, and there's going to be a big ridge in the west. So a ridge in the west is the main thing that's really going to be, you know, keeping this trough here in and around the upper Midwest, the central and the eastern portion of the United States. So and there's also going to be a ridge out here in the ocean, right? So that's going to definitely help out. You know, you could see the jet stream here, right? The storms coming from the west, they go down here, collide with tropical moisture down towards Florida, and then they go up the coast, right? You see those lines? That's kind of the tracks that the storm is going to take. So again, very, very important stuff. You know, you just take a look at the ensembles, and everything just kind of makes sense for the long term. So again, I discussed this in a previous video. I'm discussing it again today to you guys, that this is very, very important stuff that you have to just look at. And if we take a look at the GEPS, which is, I'm pretty sure, the Canadian model, right? Ensemble, so it's showing a very strong ridge out there in the west, and again, a very strong trough in the east. And right here it's showing a stronger ridge towards the northeast part of Canada, right? So basically, it's showing a more vigorous trough, which means that the storm tracks are going to be going more up the coast instead of out to sea. If the trough is more flat, then there's really not much potential for snowstorms. But if the trough is more curvy, right, you get higher energy. You get higher energy. It just makes sense. Higher energy that, you know, can create a very extreme winter storm. So we got the GEM GDPS model. Let's take a look at if we have ensembles all the way to our forecast hour 240. Okay, this model is showing again a big winter storm towards that 216 time period. I think that this storm could be extremely major, right? And because of the amount of Arctic air, even if the precipitation turns to rain, it's going to start off as snow in key areas like New Jersey, Pennsylvania, and Boston. And the fact that it's towards the end of December, we already have so much cold air. So again, just be mindful of around Christmas time. This is a very, very big snowstorm that is just waiting to happen, and we have not gotten that much snow so far this year. So again, you know, this is a very big snowstorm, I think, that is going to happen. So we take a look at the CFS weekly, and let's take a look at the 2-meter temperature anomalies from this thing. So again, looks like the cold air is going to run down into the eastern part of the United States to January 3rd, and then it kind of warms up over time, but I don't think that's true. The long term for the CFS is so inaccurate, and it kind of it likes to go on the warmer side of things usually, mainly because it kind of takes global warming to like a crazy like over exaggeration. That's just not true. All right, CanSIP's model. Let's take a look at the forecast for this winter and what it's kind of showing. Yeah, I would say that's completely inaccurate. The NMME model, right? Kind of showing like probably very high cold pressure here, and then again the troughs are going to be going down through the Midwest and then going in through the Northeast. You can kind of see that curvature with the temperature anomalies, and then we got a bunch of warm air coming in from the south. So this is just what I'm looking at, guys, and I think that I'm very accurate with what I'm saying right now. So hope you guys enjoyed this video. Have a great day, and peace out.